So guys, for us to be able to understand simultaneous equations, we need to first get down to basics and understand what is an equation first. So what is an equation? Okay, you already know that an equation represents the quantities which are equal to each other. Equations represent quantities which are equal to each other. So for you to understand quantities that are equal to each other, the best idea for you to have is to think of a balancing scale. Okay, think or visualize a balancing scale, and that's how equations would actually work, because they're quantities that represent that are equal to each other, quantities that are equal to each other. So simultaneous equations. Now, when we talk about solving simultaneous equations, we also talk about eliminations, because remember, we have equation 1 and equation 2, and we will have to eliminate one of the equations. I'm going to share my board with you, and we're going to start working. Okay, so I'm going to put down 3 examples onto my board, and then we're going to start working from there. So I'm going to say P plus 7 is equal to 11. 2m plus 3 is equal to 4, open brackets, 4 minus 4. Did I say minus 4? No, I'm sorry, not minus 4. 4 minus 2m. And the last one I'm putting on is 2r minus 4 over 3 equals to 4. Now, when we look at this, look at each one of these equations, we can almost instantaneously identify that in each of these equations there is an unknown. Okay, there is an unknown, and let's look at it. So it's P, it's the M's, and it's the R. Okay, so each of these equations have only one unknown. In the first equation, it's the P, the second one's the M, and the third one's the R. We also call these unknowns, we also call a variable. We sometimes refer to it as a variable. So in each of these cases, there is only one solution. So for example, P can only be 4, because we know 4 plus 7 is equal to 11. We know in this instance, M can only be 1. And in this bottom instance, R can only be 10. So in this instance, each of these equations only had one solution. What happens in a place where there is more than one unknown, more than one variable? So let's clear this board and let's have a look at this. 2a plus 3b is equal to 22. Okay, so in this instance, there are 2 unknowns, 2 variables to be called. Okay, this is a number of possible solutions. So guys, there's not just one straight up solution for this answer. There can be more than one. So I'm going to work with at least 2 for this particular one. So firstly, I'm going to say A is equal to 2 and B is equal to 6. 2A plus 3B is equal to 22. Then I'm going to say 2 times 2 plus 3 times 3, 3 times 6. 3 times 6. And 2 times 2 is 4, plus 3 times 6 is 18, and 4 plus 18 is equal to 22. Now, that is just one solution to this. Like I said, there's more than one possibility for this. If I clear this board out and I do another one, if I say A is equal to 5 and B is equal to 4, and I say 2A plus 3B is equal to 22, and I say 2 times 5 plus 3 times 4, okay, 2 times 5 is 10, and 3 times 4 is 12, and 10 plus 12 is equal to 22. Okay, so now you can see how there can be more than one solution to this possible equation. We know that these solutions are both correct because in both instances, when the values are substituted, the left-hand side of the equation equals to the right-hand side of the equation. However, if there are two equations both involving the same unknowns, they are called simultaneous equations. If there are two equations both involving the same unknown, we call this simultaneous equations. Okay, so now let's try and work out some simultaneous equations. So if I have 2a plus 3b is equal to 22, and I call that equation 1, and I say 2a plus b is equal to 14, and I call that equation 2. Okay, how can we find a solution which satisfies both equations? Okay, first let's try this. A is equal to 2b, A is equal to 2 and b is equal to 6. We'll call that equation 1. Okay, and then we'll say 2 times 2 is equal to 2 times 2 plus 3 times 6 is equal to 22. You know, 2 times 2 is 4 and 3 times 6 is 18. And if we add them both up, they're 22. Now, let's say A is equal to 2 and B is equal to 14. And we say 2A plus B is equal to 14. We say 2 times 2 plus 6 is equal to 14. And then we say 2 times 2 is 4, plus 6 is equal to 10. Now, 10 is definitely not equal to 14. So in this instance, the value of the left-hand side does not equal to the value of the right-hand side. So the solution is not the same for both sides of this equation. Okay, do you understand that? This is not a solution for both sides of the equation because when we worked out equation 2, the answer we got was not correct. Now, let us go to your maths textbook, the Checkpoint Maths 3, and I'm going to turn to page 88, and I'm going to start off with exercise 9.3. I'm going to give you guys a few seconds to just get a hold of your textbooks as I clean out my board. Okay. Now, if I have to say exercise 9.3b says solve each of these pairs of simultaneous equations by elimination. So let's first look at the first one. It says 3a plus 2b is equal to 10. And we've got 2a plus 2b is equal to 8. Now, we're going to call the first one equation 1 and equation 2. Okay, so now, what do we do first? Let's start with equation 2 first. If we say 2b is equal to a minus 2a, and we substitute equation 2 into equation 1, what will it look like? We'll be saying, using equation 1, we'll say 3a plus 8 minus 2a is equal to 10. 3a, therefore, plus 8 minus 2a is equal to 10. 3a minus 2a is equal to 10 minus 8, because now we've transferred over. taken the 8 across. And what is 3a minus 2a? It's just going to be a because its value is 1. What is 10 minus 8? It is 2. Okay, and that's how we would solve it out if we look at how we're going to substitute equation 2 into equation 1. Okay, let's do number 2 on that one. It says 3c plus 4d is equal to 13. And we're going to call this equation 1. And c plus 4d is equal to 7. And we're going to call that equation 2. Okay, so starting first with equation 2, we can say 4d is equal to 7 minus c. Okay, this is equation 2. Okay, now we're going to substitute. We're going to substitute equation 2 into equation 1. Okay, and now what are we going to say? We're going to bring this down. We're going to say 3c plus what we just worked out, 7 minus c is equal to 13. Then we're going to say 3c minus c is equal to 13 plus 7. Okay? And then 3c minus c is going to give us 2c, and 13 plus 7 is going to equal to 20. Therefore, c is going to equal to 10. So this is 20. Okay. Now, that was 2 easy ones. Let's move over to, let's do number 8. Okay? Number 8 is number 8 goes like this. It says 3q plus 2r is equal to 14. And q plus 2r is equal to 6. This is equation 1. And this will be equation 2. Okay, now, guys, let's just quickly make sure that everybody is on the same page and everybody is calculating. You guys are all on page 88 and we're still busy on exercise 9.3b, and now I'm on number 8. Okay, so let's look at this. Okay, we said this is equation 1 and equation 2. Firstly, starting with equation 2, I'm going to start off with 2r is equal to 6 minus q. Okay, and that is equation 2. Okay. Okay. Substitute equation 2 into equation 1. And how do we do that? We start off at the top. We say 3q, and then what did we work out? Was that we say plus 6 minus q is equal to 14. Then we say 3q minus q is equal to 14 minus 6. 3q minus q is equal to 2q, and 14 minus 6 is equal to 8. Therefore, q is equal to 4. Okay, that was slightly a little bit more confusing, but you guys understood what was going on. Now let's do a different one. So we've done 2 from the top ones and they were simply easy. We did a middle one, that was okay. Let's do number 14. Number 14 goes like this. It says G plus H is equal to 3. Okay. G plus H is equal to 3. So we're going to call this equation 1. Okay. And the next part of it says G plus 3H is equal to 7. And that's going to be equation 2. Okay. Starting once again with equation 2, we're going to start off by saying G is equal to 7 minus 3H. Okay, 7 minus 3H. And that is equation 2. Now, we're going to substitute equation 2 into equation 1. And we're going to start off by saying 7 minus 3H plus H is equal to 3. Okay, 7 minus 3H plus H is equal to 3. 7 minus 3 is equal to 3H plus H. 4 is therefore equal to 4. 7 minus 3 is equal to 4. 3 plus H is equal to 4H. 1 is therefore equal to H. Okay, so we've worked a few of the examples on 9.3. Let's have a look at 9.3c. Okay, so now we're going to do a few examples from 9.3c. And it says solve for each of these pairs of simultaneous equations by the process of elimination. So once again, we're working with the process of elimination by solving the equation pairs. So on there, I'm not going to start with number 1. I'm going to go straight to number 3. Okay, so we just increase the level of difficulty so that we have exposure to different or variety of equations. So number 3 says 2D plus E is equal to 7. And we're going to call this equation 1. Okay, and then 3D plus 2E is equal to 12. And we're going to call this equation 2. Once again, we're going to start with equation 2 first. And we're going to say 2E is equal to 12, transferring over, minus 3D. And that's now equation 2. And then what do we do next? Before we go on, we're going to say another part to our equation 2. We're going to say E is equal to 12 minus 3D, yes. So we're going to say E is equal to 6 minus 1.5D. And then we're going to substitute equation 2, and we're going to say 2D plus 6 minus 1.5D is equal to 7. And then we're going to say 2D minus 1.5D is equal to 7 minus 6, which is then equal to 0,5 is equal to 1. And therefore, D is equal to 2. Okay, let's do number 4. That one was a little bit tricky. Let's do number 4. Number 4 says 3F plus G is equal to 11. And we're going to call that equation 1. Okay, then it's 2f plus 3g is equal to 12, and we're going to call that equation 2. Then starting once again with equation 2, we're going to say g is equal to 11 minus 3f. Okay? And we're going to call that equation 1 this time. Okay, we're doing that one. Then we're going to substitute equation 1 into equation 2. We're going to substitute equation 1 into equation 2. Okay, and how do we do that? We're going to say 2f plus 3, open brackets 11 minus 3f is equal to 12. 2f plus 33, because we're multiplying, minus 9f is equal to 12. So our answer here with 3 multiplied by 11 is 33. 3 times 3 is 9, and is equal to 12. Then we say 33 minus 12 is equal to, no, 33 plus minus 12 plus 9f minus 2f is equal to 33 minus 12 is equal to 21 is equal to 7f. 3 is therefore equal to f. Okay, so guys, we've covered a few examples of simultaneous equations, and we've learned a few things today. So let's do a quick recap of all the things we've learned today. We know that the solutions are correct when the values that are being substituted on the left-hand side of the equation equals to the value on the right-hand side. And we've also learned that if there are two equations, both involving unknowns, they are referred to as simultaneous equations. The other thing we worked with is, and we've already established it, when we're talking about the word equation, we're talking about a balancing scale. We know equations represent two quantities which are equal on each side. And the easiest way for us to know that or to visualize it is when we are talking about a scale. Okay. I hope you guys feel like you've learned something here today, because that was important for me to work a little bit extra with you guys on simultaneous equations. I know some of them were a little bit more difficult, but guys, I would urge you to go back, recap on this video, and actually make friends with simultaneous equations. Go through the examples I've done for you and try and solve it yourself and see if you can work through it. Before I actually say bye to you guys, I want to do just one more for you, and I'm going to go to actually exercise 9.3, because I see that one also looks a little bit, can be a little bit tricky if you look at it. And it says, form a pair of simultaneous equations for each of these solutions. And I'm only going to do number 5 and maybe number 6 for you before our time goes out. So I'm going to quickly clear my board, and I'm going to do number 5. And number 5 is j is equal to 7 and k is equal to 1. Okay, j is equal to 7 and k is equal to 1. And what we say here is j plus k is equal to, and now we need to find a solution and find our answer. So how will we work that out? We're going to say is 8, open bracket, 7 plus 1 is equal to 8. And that's how we get equation 1. And then we say 2j plus 2k is equal to 16. We'll open brackets, 14 plus 2 is equal to 16, and we'll call this equation 2. And that's how we will have a solution for this particular in this particular equation. So let's do number 6. Number 6 says 1 is equal to minus 1, m is equal to 2. Okay, and how do we work out this? 1 is equal to minus 1 and m is equal to 2. So once again, we're going to say L plus m is equal to 1, open brackets, minus 1 plus 2 is equal to 1. And we're calling this equation 1. Then we're going to say 2L plus 2m is equal to 2, open brackets, minus 2 plus 4 is equal to 2. And that's how we have equation 2. Okay, so guys, we've worked a bit on 9.3 B, 9.3 C, 9.3 D. I encourage you guys to go back, keep working on simultaneous equations, and try and break down as many solutions as you can and work at as many as you possibly can. And I know that you'll, before long, you're going to make good friends with simultaneous equations, and it's going to be easy peasy when you guys are working with it, and work until you are comfortable with it.